It's Algebra 1, Lesson 4.2, Graphing Linear Equations. We're graphing these using tables or list of values, and then we're going to graph horizontal and vertical lines beginning on page 210. Got a couple of definitions. First thing is a solution of an equation. Remember, it's a solution of an equation if it makes a true statement. So a solution in two variables when you have x and y is an ordered pair that makes the equation true. So we'll look at some examples about that in just a second. The graph of an equation in x and y is the set of all points that are solutions of the equation. So every point, and it's an infinite amount, that falls on the line itself or something that creates a line when we're talking about linear equations, which we'll focus on here. Example number one is verifying solutions of these equations. It says use the graph to decide whether the point lies on the graph 2x plus 3y equals -6. So algebraically, we can justify it, and graphically, we can justify it. Graphically is the way you can do it very quickly. So for the first one, it says 3, -4. Remember which one's which. This one's x, and this one's y. So this is your x-axis, the one going across. Y is the one going up and down, your vertical axis. So at 3, -4, 1, 2, 3, -4, it passes through that point right there. So graphically, we can see it falls on that line or it falls on that graph. Therefore, it is a solution. When you check the other one, which we'll check in just a second, -4, +1, which is here, you can see that it doesn't fall on it graphically. Algebraically, we could check it by plugging in those 2 points. X's value is 3, so in place of x, 3, and y's value is -4 in place of y, -4. And we see if we get a true statement. 2 times 3 is 6. 3 times -4 is -12, and 6 minus 12 is in fact -6, which gives you a true statement there. -6 is equal to -6. The other one again, -4, 1, is not a solution. Graphically, we could see it at -4, 1. It's very close, but it does not pass through the line. Notice how it does not pass through that point, -4, 1. So it is not a solution. Algebraically, again, it's -4, 1. So this will be x, this will be y. So in place of x, -4, in place of y, 1. 2 times -4 is -8, and 3 times 1 is +3. -8 plus 3 is -5. That is not equal to -6. Therefore, it is not a true statement. So graphically, we can see that it doesn't pass through the line. Algebraically, we can see that it is not a true statement at the end. -5 is not equal to -6. On the back, everybody, let's do this one. You don't have to copy this graph down. Just see it as you look at it. Check this first point, 4x plus y equals 8. Check the point 1, 4, and see graphically if it works. And then it says justify your answer algebraically. So algebraically plug them in and see if the statement is true or false. Take about 20 seconds to do that. Okay, graphically we could see 1, 4. That point 1, 4 absolutely falls on a line. So algebraically, we should get a true statement. 4 times x's value is 1, plus y's value is 4, is equal to 8. 4 plus 4, this is a true statement. 8 is equal to 8. So algebraically, we could check it. Let's do the same thing. Graphically check 3, 4, and then algebraically justify it. Take about 25 seconds. Graphically, very quickly, we can determine that it is not a solution. 3, 4 absolutely doesn't pass through the line. So it should not be a solution. Let's check it algebraically to make sure. 4 times x plus y is equal to 8. 4 times x is 12 plus 4, 16 is not equal to 8. We can see very clearly that is not a true statement. So that's doing it both graphically and algebraically. Graphing a linear equation. The first thing you want to do is rewrite an equation in function form. Remember, anytime you see this phrasing function form, that just makes it say y equals. Don't let that confuse you. Rewrite it as y equals. Step 2, choose a few, we'll say 5 for now. Choose a few values of x and make a table of values. I'm pretty sure it was somebody in this class that said something about checking it with 3 points. You only need 2 points to make a graph. But the third point will check to see if something's wrong or not, if it's not in a straight line when you graph it. Okay. Right now, we'll do 5 to where we get used to it. I'll show you a much faster way to graph after you understand this way first. The other way won't make sense until you understand this way. Then make a table of values. Then plot the points from the table of values. Draw a straight line through the graph. Example number 1. Let's use a table of values to graph the equation. The first thing we want to do is write it in function form. Notice off to the left it says after an equation is rewritten in function form, it is easier to make a table of values. You could do it without rewriting it, but it is much easier if you isolate y all by itself. So if we want to get y by itself, just like the bell work, move x over by subtracting x on both sides. Once you subtract x on both sides, divide everything by 4. Remember, when you divide one thing by 4, it's not like terms. You divide every term by 4. Remember, negative x divided by 4 is negative 1 times x divided by 4, which makes it say negative 1/4 x. And 4 divided by 4 is 1. So at this step, you have it written in function form. And even more specifically, it is in slope-intercept form, which we'll talk about in the next lesson. Y is equal to negative 1/4 x plus 1. If you go back to your steps from your right here, after you rewrite it in function form, it says choose a few values of x. Remember, we're going to talk about 5 for right now, though. It just tells you to pick a few of them. They use negative 4, 0, and 4. Now, I told you previously to use numbers like negative 2, negative 1, 0, 1, and 2. Why does it choose to use negative 4 and positive 4? Anybody can take a guess at that? What we're multiplying by in this case, the reason they chose the numbers 4 and negative 4 is because of the reciprocal 1/4, which is the same thing as divided by 4. So in this case, which this sometimes happens, most of the time your numbers 2 and 1 and 0 are going to be your easiest versions to work with. But in this case, since it says 1/4 and it's negative 1/4, since it's 1/4, it's easier to multiply by the reciprocal 4 and negative 4. So when you work this equation, negative 1/4 times negative 4, you get positive 2. Positive 2, and you get 1, I'm sorry, and then when you add that to 1, you get positive 2. When you plug in 0 times that, you get 0. That plus 1 is 1. And when you plug in positive 4, you get negative 1, and negative 1 plus 1 is 0. So these are your y values. There's no input-output table. It's simply, it skips all of the middle part for you because these are easy numbers to multiply by. And then we said, again, going back to this, after you have a table of values, graph the ordered pairs. This is one ordered pair, negative 4, negative 2. So at negative 4, negative 2, these are just the solutions written as ordered pairs. Negative 4, negative 2 right here. 0, 1 is another one, 0, 1. And 4, 0 is the next one, which is kind of off my paper, but 4, 0. It should fit on you guys' paper. 4, 0. And once you have all three of those points right there, draw yourself a straight line. On the back, everybody, I want to graph this one the same way. 5x is equal to y minus 2. First step, take 20 seconds for your first step and make it written in function form. Get it to say y equals all by itself. Okay, the first thing you need to do is move 5x over. Or we want to get y by itself. Now, look how y is over there with negative 2. Instead of moving 5x over, if we want to get y by itself, let's move over negative 2 by adding 2 to both sides. So plus 2 and plus 2. Remember, we don't get 7x. Those are not like terms. So we get something that says y equals 5x plus 2. Is this written in function form? Is y all by itself? Yes, it doesn't matter, and this is what some of y'all might be thinking, since y is on the right side, it's not function form, it doesn't matter. Because you can say that in your mind, you could read that as y equals 5x plus 2. So that is function form. So now from there, y equals 5x plus 2. Let's use our x values, negative 2, negative 1, 0, 1, and 2. And let's get some y values from that. So real quick, work that out. Take about 30 seconds. You should get 5 separate answers. Okay, so let's go through these real quick. The first one, when we plug in negative 2 in place of x, 5 times negative 2 is negative 10. So we got negative 10 plus 2 is negative 8. That's what you should have for your first one. Negative 1 times 5 is going to be negative 5 plus 2. When you put those two together, you get negative 3. 0 times 5 is 0 plus 2. You're going to get 2. 1 times 5 is 5 plus 2. You're going to get 7. And finally, 5 times 2 is 10 plus 2. You're going to get 12. So now notice now we have 5 points that we can graph. So let's graph an equation with all of these values. So we got to go all the way to 12 with this one. So the first one, negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, negative 8 is going to be right there. The second point, negative 1, negative 3, negative 1, negative 3. Remember, x comes first, y comes second. So you go left 1 and down 3. The next one, 0, 2, is going to, you're not going to go right or left at all, but you're going to go up 2. The next one, 1, 7, we're going to go to the right one time, and we're going to go up 7. 2, 3, 4, 5, 6, 7. I know we got to get all the way to 12 in a minute, but at 1, 7 goes there. And then the last one, 2, 12, we're going to go 1, 2, and we're going to go up 12. We already got 7, 8, 9, 10, 11, 12. We're going to show an estimated point at 2, 12, about right there. So using all 5 of those points, we could draw ourselves a straight line. It's not as curved as the one I just drew because I freehanded it on this computer screen. But we have 5 points in a straight line that we can draw a line through. Again, some of y'all are looking at this and saying this is a lot of work. It is. If you don't understand how to do this, you won't understand how to graph them the quick way that I'm going to show you in the next lesson. Nor will you understand how to graph quadratics when you get to Algebra 2, which most of y'all are planning on going to in a couple of years. So this is the easiest way to graph. This is the way to graph that always works. Plug in points, plug in x's, get y's, and then when you have those values, go ahead and graph them. This is the way that always works. Okay, the checkpoint says use a table of values to graph the equation x minus 2y equals 1. So the first thing we want to do is we want to get y by itself, get it in function form. Move positive x over by subtracting it. So if you subtract it there, you're left with negative 2y equals 1 minus x. Now, you can't take those apart from each other. Get y by itself by dividing by negative 2. Remember to divide everything by negative 2. So y is equal to negative 1/2. Negative divided by negative is a positive 1/2 x. So if we rewrote that like we did on the bell work to say mx plus b, it would say positive 1/2 x minus 1/2. So this is function form here. So now let's make ourselves a table of values with, let's just use 3 values so we can go a little faster this time. Let's use negative 2, 0, and 2. And remember what we discussed earlier. 1 is not the easier value to multiply by in this case. The reciprocal 2 is. So when we plug that in, 1/2 x minus 1/2 times 2, or times negative 2's first. Half of negative 2 is negative 1 minus 1/2 is negative 1.5. Let's leave it like that. It's easy to graph negative 1.5. 0 times x is, 1/2 times 0 is 0. And then 0 minus 1/2 is negative 1/2. And then 2 times 1/2 is 1. 1 minus 1/2 is positive 1/2. So if we graph each one of those points, negative 2, negative 1.5 will be there. 0, negative 1/2 will be there. And 2, positive 1/2 would be there. You have 3 points. You could graph yourself a line, and we'll finish with the second part of this tomorrow.